The Subcommittee on Information Technology will come to order, and without objection, the chair is authorized to declare a recess at any time. Good afternoon. Welcome to the Oversight and Government Reform hearing on artificial intelligence. This is the second in a series of hearings on artificial intelligence, and this series is an opportunity for the subcommittee to take a deep dive into this issue. I have three main objectives when it comes to AI in government. First, it should make every interaction an individual has with the federal government take less time, cost less money, and be more secure. I have wonderful caseworkers on staff who spend their time working to help constituents receive their veterans benefits or to help with Social Security. They're speaking every day with people who are frustrated with how long it takes to resolve problems in the federal government. I believe with the adoption of AI, we can improve the response time and in some cases, prevent these problems in the first place. Second, AI should produce efficiencies and cost savings that will help us do more for less money and help to provide better, more transparent citizen-facing services. This should help to restore the bonds of trust between citizens and their governments. We have innovative companies, brilliant minds, hardworking people, and the rule of law. So we, the United States, should lead on AI, and the federal government needs to be an active participant. Whether it is through basic and applied research and development that DARPA, NSF, and DHS are doing, or GSA's work on procurement, the AI within the government needs to benefit those whom the government serves. I thank the witnesses for being here today, and I look forward to the hearing and learning more from all of you. And I'll be honest, at the beginning of this endeavor, I was prepared to not see much use of AI throughout the federal government, and I think our panelists here today are going to show how we're doing some very interesting things in the government. And as always, it's an honor to explore these very important issues in a bipartisan fashion with my friend and ranking member, the one and only Robin Kelly from Illinois.
Thank you, Mr. Chairman. Mr. Chairman, thank you for calling today's important hearing on federal agencies' adoption of artificial intelligence, or AI. This is the second hearing in a three-part series of hearings on AI. Today's hearing focuses on the federal government's adoption of this technology. AI has the potential to make government more efficient and decrease costs across agencies. To fully realize the benefits of AI, the U.S. must maintain its leadership role in promoting technological innovation. Yet preserving the United States' leadership role in technologies like AI will require robust federal funding for research and development. But at our first hearing on AI, Intel's Chief Technology Officer for AI warned us that, quote, current federal funding levels are not keeping pace with the rest of the industrialized world. In fact, President Trump's proposed budget for FY 2019 cuts or flattens non-military agency budgets for R&D. As you can see on the screens, the trend is so clear that the National Science Board and the National Science Foundation believe that China will surpass the United States in R&D investments by the end of this year. The chart displayed demonstrates China's rapidly growing investment and the U.S. ceding its position as a leader in AI. The future of U.S. innovation is at stake. This should be a cause of concern for everyone. Outside of the Department of Defense, the President's budget proposes an overall cut to research and development of 21.2%. Consider, for example, the National Science Foundation, whose investments in R&D have led to innovations that improve our everyday life. From Google to LASIK eye surgery to cloud computing, all can be traced to NSF investments in technology. This chart shows President Trump's precipitous drop in non-defense R&D spending. In an agency like the National Science Foundation, which supports basic research in colleges and universities and in the private sector, this budget represented almost a 29% decrease from the agency's actual spending levels in 2017. These budget cuts take the United States in the wrong direction. Another troubling trend for the U.S. is that we are not making the critical investments today to educate the workforce we need to sustain these industries of the future. The displayed chart shows the number of science and engineering undergraduates in China compared to the United States. As you can see, we are not keeping pace with China, which is displayed in red. Yet another troubling factor is this administration's hostility to immigrants. Until recently, the U.S. was able to attract Ph.D. students from other countries to help supplement the domestic workforce. The New York Times reported last year that not only is Google opening AI innovation hubs in Canada because of concerns with American immigration policies, but that the U.S. has already turned away promising people in the AI field. Unfortunately, this administration's science, immigration, and education policies are all working together to reduce the U.S. lead in AI technologies. I hope today we can discuss the policies and funding necessary to ensure we remain competitive in this area. Again, I thank you, Mr. Chair, for having this hearing.
Thank you. And I'm pleased now to introduce our witnesses. Our first is Dr. John Everett. He's the Deputy Director of the Information Innovation Office for DARPA. Mr. Keith Nakasone. He is the Deputy Assistant Commissioner for the Office of Information Technology, category for the Federal Acquisition Service at GSA. Say that 3 times fast. Dr. James Kurose is the Assistant Director for Computer and Information Science and Engineering at National Science Foundation. It's always a pleasure to have you here, sir. And last but not least, Dr. Douglas Maughan is the Division Director of the Cybersecurity Division in the Homeland Security Advanced Research Projects Agency at DHS. Welcome to you all, and pursuant to committee rules, all witnesses will be sworn in before you testify, so please rise and raise your right hand. Do you solemnly swear or affirm that you're about to tell the truth, the whole truth, and nothing but the truth, so help you God? Thank you. Please let the record reflect that all witnesses answered in the affirmative. In order to allow time for discussion, please limit your testimony to 5 minutes. Your entire written statement will be made part of the record, and as a reminder, the clock in front of you shows when your remaining time, the remaining time you have. It's going to turn yellow when you have 30 seconds left, and when it flashes red, that means your time is up. And also remember to press the button to turn on your microphone before speaking. Now, I'd like to recognize Dr. Everett for your 5 minutes of opening remarks.
Good afternoon, Chairman Hurd, Ranking Member Kelly, and distinguished members of the committee. I appreciate the invitation to give testimony on the state of AI research today. My name is John Everett, and I'm the Deputy Director of the Information Innovation Office of the Defense Advanced Research Projects Agency, DARPA. DARPA's mission is to create and prevent technological surprise. We do so by funding research programs, each with a specific goal to advance the state-of-the-art in a particular area. This strategy has served the country well, by leveraging academia and industry R&D labs to develop the enabling technologies for new defense capabilities and to plant the seeds for new industries, such as the internet and self-driving cars. Since the 1960s, we have funded more than 50 programs in AI. AI technologies have developed in 2 waves. The first wave focused on abstract logic and reasoning tools that require explicit representations of knowledge in the form of handcrafted rules. The second wave, machine learning, uses algorithms to extract implicit representations of knowledge from large amounts of data. The first wave started in the 1950s and explored many hard problems in reasoning, understanding natural language, and robotics. It produced many algorithms that are in common use today, such as planning and scheduling systems. Researchers quickly discovered the importance of world knowledge in solving problems and created expert systems that use rules to represent knowledge about a particular subject area, such as diagnosing infectious diseases. An early DARPA-funded expert system rivaled human performance in this area. However, as we all know, for every rule there is an exception, and the work necessary to capture sufficient knowledge proved impractical in many cases. The second wave started in the 1990s in reaction to the difficulty of capturing world knowledge by writing it down. The most successful form of machine learning today is called a neural network because it is inspired by the structure of the human brain. Machine learning uses large amounts of data to train an algorithm to do a specific task, such as recognize speech, drive a car, or search for pictures of, say, people playing frisbee on a beach. However, these algorithms cannot explain their conclusions, which makes them hard to trust. Also, researchers have shown that sometimes imperceptible changes to an input image, say of a panda, can cause the algorithm to confidently misclassify it as a monkey. Nonetheless, the second wave of AI has yet to crest, and researchers will continue to improve the technology and develop interesting and innovative applications. We believe that the next wave of AI will combine insights from the first and second waves to produce systems that are aware of context so they can interact more effectively with people. This will require major advances in common sense reasoning and natural language processing. Context is the shared understanding that people have with each other. It enables highly concise communication through speech, intonation, facial expressions, and gestures. Such communication is extremely difficult for current algorithms to understand, making this an ideal area for DARPA research. Thank you.
Thank you, sir. Mr. Nakasone, you're now recognized for 5 minutes.
Good afternoon, Chairman Hurd, Ranking Member Kelly, and members of the subcommittee. Thank you for the opportunity to appear before you today. My name is Keith Nakasone, and I am the Deputy Assistant Commissioner for Acquisition Operations in the Office of Information Technology category at GSA. I've been a participant in the growth of emerging technologies in government over the past 20 years, including during my years at the Defense Department. Mr. Chairman, at the first hearing in this series, you stated that it was your hope agencies would use today's discussion to inform Congress how we plan to use artificial intelligence to spend taxpayer dollars wisely and make each individual's interactions with government more efficient, effective, and secure. I would like to discuss 4 ways in which our agency is supporting government AI evaluation and adoption to accomplish that. First, our Federal Acquisition Service provides contracting vehicles and mechanisms, including Schedule 70, as well as several other government-wide acquisition contracts, which encourage competition and help connect agencies and businesses to allow government to efficiently procure the most effective new AI services and capabilities. GSA's IT Schedule 70 contracts provides federal, state, local, and tribal government agencies with access to over 7.5 million best value IT and telecommunications products, services, and solutions for more than 4,600 pre-vetted vendors, including firms whose offerings use AI as similar technologies. Oops. Since emerging technology businesses frequently tend to be startups, Schedule 70 offers 2 shortcuts, Startup Springboard and Fastlane, as part of the Making It Easier initiative, which aims to streamline the process for younger, innovative companies and suppliers to do business with government. Second, GSA is piloting robotic process automation and related technologies designed to augment our workforce and achieve more with less while establishing a foundation for greater data-driven decision-making through AI. GSA has developed a new pilot using AI for prediction of regulatory compliance. The solicitation review tool uses natural language processing, text mining, and machine learning algorithms to substantially alleviate the human resources needed to identify, audit, and enforce compliance of solicitations posted on fbo.gov. Further, GSA recently launched 2 pilots exploring the use of robotic process automation and distributed ledger technology, foundational technologies that can open our programs to better decision-making through AI. These pilots aim to increase GSA's operational efficiency, reduce costs, improve processes, increase accuracy, and redeploy staff to higher value functions. Third, our Interagency Emerging Citizens Technology Office unites more than 2,000 government managers from over 300 federal, state, and local agencies and representatives from businesses, startups, and research and civic organizations to support and coordinate government-wide development of citizen-facing AI and other emerging technology programs, including through resources at emerging.digital.gov. Recent initiatives include the launch of an interagency venture capital advisory group and a new education and training pilot. Fourth, along with our private sector and federal agency partners, we are pursuing a greater understanding, alignment of IT modernization through cloud adoption, data services, and emerging technologies, including AI, that deliver the greatest benefit to the American people. For instance, through data.gov and ECTO, we are learning how to improve the standardization and accessibility of government open data to help fuel innovation. We have solicited input from industry partners on how to improve data hosting so data sets are more easily digestible for AI and machine learning. GSA is essentially a shared service. and we are constantly seeking ways to develop government faster, better, and smarter. AI is a tool that can expand the value proposition for federal agencies, vendors, and the American people alike. Thank you again for the opportunity to testify. I look forward to your questions.
Dr. Kurose, you now have 5 minutes.
Thank you very much. Good afternoon, Chairman Hurd, Ranking Member Kelly, and members of the subcommittee. My name is Jim Kurose. I'm the Assistant Director at the National Science Foundation for the Directorate of Computer and Information Science and Engineering. As you know, NSF contributes to national security and economic competitiveness by supporting fundamental research in all areas of science and engineering, as well as education for the next generation of discoverers. I welcome this opportunity to highlight NSF's AI investments. Federal investments in foundational AI research are critical to achieving and sustaining U.S. science and technology leadership. Fundamental AI R&D challenges can be broadly classified into two categories. First, there's narrow AI that is focused on solving specific tasks in well-defined domains, such as speech recognition or image classification. Here, NSF-funded researchers have pioneered new machine learning techniques and applied these techniques, for example, to analyze breast cancer and predict sepsis. To your opening remarks, Chairman Hurd, NSF is piloting the use of AI clustering techniques in its own business processes to help program managers select proposal reviewers. The second broad category, general AI, is about transferring what is learned in one setting to another and ultimately appreciating intent, meaning, and understanding. Several witnesses in your earlier panel have noted that these goals remain an AI grand challenge in which we're also investing. In fiscal 17, the National Science Foundation invested more than $120 million in core AI research. AI will continue to be an important part of our research portfolio, including NSF's big ideas. Indeed, NSF Director Dr. Franz Cordova, my boss, recently described AI as, quote, the universal connector that interweaves all of our big ideas. Data science is changing the very nature of scientific inquiry, and AI's use of data has the potential to revolutionize everything we do in science. The AI innovations that we are seeing today are built on earlier fundamental research. For example, NSF's investments in reinforcement learning decades ago are enabling today's deep learning systems in autonomous vehicles. As Eric Schmidt, former Google Alphabet CEO, has said, NSF is, quote, where all interesting research gets started. Well, yes, we're a starter, but we're also more than that. We're part of a larger, very uniquely American research and innovation ecosystem among academia, industry, and government, with the flow of ideas, artifacts, and people across these sectors. This ecosystem has given rise to multi-billion-dollar industries, including AI. But truly, it all begins with investment in fundamental long-term research, often made with federal research dollars. At NSF, we're constantly exploring new partnership models to grow this ecosystem. We've partnered with industry on joint research solicitations. Recently, we combined $50 million from the National Science Foundation with an equivalent amount from an industry consortium to advance wireless technologies. These public and private partnerships serve as models for potential future AI R&D collaborations. Federal agencies, like my colleagues here, are other partners. NSF co-chairs the Networking and Information Technology Research and Development Subcommittee of the National Science and Technology Council, and we co-chaired an NSTC committee that developed the 2016 National AI R&D Strategic Plan. You've heard that much of the AI revolution has been enabled by the availability of large data sets and computing. NSF has invested in open training data sets and is committed to public access to data resulting from federally funded research. NSF has also long invested in high-performance computing. To complement these investments, we recently announced a partnership with 3 commercial cloud providers, Amazon, Google, and Microsoft, to make $12 million in cloud resources available to academic researchers through our big data program. Beyond data and computation, there remains the most valuable resource of all, people. NSF investments here include research that builds the foundations for rigorous, engaging computer science education at all levels, K through 12, university, and lifelong learning. For example, working with the teaching community and many partners, NSF support led to a new advanced placement computer science principles course, whose launch last year was the largest ever in the College Board's history. More than 50,000 students took the exam. We saw remarkable strides in participation of groups long underrepresented in computing as well. More than double the number of African Americans, Hispanics, and women took this new AP exam in 2017 as compared to the existing CSAP exam the year before. NSF's investments and partnerships have helped sustain the nation's leadership in AI and enhanced our nation's economic competitiveness and security. We at the NSF are committed to continuing this investment in fundamental AI research, infrastructure, and workforce to maintain U.S. global leadership. This concludes my remarks, and thank you again for the opportunity to address this subcommittee.
Thank you, sir. Dr. Maughan, you're now recognized for 5 minutes.
Chairman Hurd, Ranking Member Kelly, and members of the subcommittee, good afternoon, and thank you for this opportunity today. I will be sharing important aspects of how the Department of Homeland Security Science and Technology Directorate, or S&T as it is known, is using artificial intelligence-based technologies in research and development and working across all DHS mission areas to integrate innovative technologies into everyday use. As the R&D arm of DHS, S&T develops the tools, technologies, and knowledge products for DHS operators and state and local first responders, ensuring the R&D coordination across the department to develop solutions for the needs of today and tomorrow. S&T partners with federal agencies, as Jim said, industry, academia, and international government to create and test solutions that help the nation's Homeland Security officials prevent, respond to, and recover from all hazards and threats. S&T's goal is to provide real-world solutions in a realistic time frame. AI offers much promise. From a government perspective, it holds the potential for enhanced insight into public service operations and improved delivery of citizen services. Examples span the range from helping people navigate immigration systems to predicting and preempting threats and enabling resilient critical infrastructures that today are under attack. AI technology is improving our knowledge and actions, fueled by sensors, data digitization, and ever-increasing connectedness. AI filters, prioritizes, classifies, measures, and predicts outcomes, which can have significant impact on people. Private industry is leading the way in AI development because many see its implementation as a key competitive advantage. Government must be informed and ensure AI technology is being used to create efficiencies and enhance the public good. At DHS S&T, AI is a part of several ongoing Cybersecurity Division research initiatives, which are using AI and machine learning techniques for predictive analysis of malware evolution against future malware variants, detecting anomalous network traffic and behaviors to inform decision-making, and helping identify, categorize, and score adversarial telephony denial-of-service techniques. For example, S&T developed a machine learning-based policy engine capable of blocking more than 120,000 calls per month, including robocalls. This same technology can be used to defend 911 centers against life-threatening distributed denial-of-service attacks. DHS S&T also is working closely with the nation's startups on AI through our Silicon Valley Innovation Program, or SVIP. Launched in 2015, the department is connecting with innovation communities across the nation to harness the commercial R&D ecosystem for technologies with government applications and help accelerate transition to market, with the goal of reshaping how government, entrepreneurs, and industry work together to find cutting-edge solutions for the department operators. SVIP and Customs and Border Protection are partnering on AI and machine learning topics, including visualization, predictive models, and entity resolution, and currently are funding startups to exchange information and intelligence, build capacity, and increase worldwide security and compliance standards. Looking forward in AI, DHS continues to support the design of AI systems in a manner that makes the actions and decision-making of technologists, government officials, and other users both transparent and understandable. The design, development, implementation, and evaluation of AI solutions should generate trust that the government and industry are innovating responsibly by demonstrating that the government is balancing risks in delivering on its mission to serve the public fairly and justly and influence responsible evolution and the role for AI in the private sector. In order for the government to be relevant in this fast-moving and competitive future that is being defined by AI, innovation should be advanced through an emphasis on responsible R&D. In addition, AI R&D should involve multiple disciplines and those perspectives that involve experts not only from computer science, but also the other physical and social sciences. Mr. Chairman and members of the subcommittee, AI is here to stay. This reality means that S&T must aggressively work with its research, development, test, and evaluation partners throughout government and industry, so Homeland Security applications of AI and machine learning are both effective and trusted. Thank you for your thoughtful leadership on these issues. I look forward to your questions.
Thank you, Dr. Maughan. My first question to the panel, it's for all of y'all, and y'all are here as the representation of some of the best things that are happening when it comes to AI across the federal government. And one of the things that we heard in the last panel and we've heard in conversation on this topic, two things that the federal government can be doing. Research, obviously, right? Continued basic research, applied research, like some of the things that Dr. Maughan is doing at DHS. I'm in, we get it, we're gonna try to figure out how to do that, right? This is a bipartisan issue. The second thing we've heard is also data. You know, how do we unlock data that the federal government has that can be used to train and teach these various algorithms? I get those two things. But I'm asking each one of y'all, and this doesn't have to apply to just your agency, but across the federal government, what is one thing that the federal government should be doing now in implementing artificial intelligence, something that's available, something that can be used, that we should be doing? Is that a fair question? Dr. Maughan, you shaking your hand? Yeah. Dr. Maughan.
Sure. So, I mean, things we are doing already include, as I mentioned with our Customs and Border Protection folks, they have something called the Global Travel Assessment System, GTAS, which they make available to all of our international partners as well. And we have been working with them to add in capability into that open source system that are AI-based. And so we're starting to see that roll out as new capability for not only CBP, but all of our international partners.
Dr. Kurose.
Well, thank you, and thank you for mentioning the importance of funding basic research and open data as well. You know, I had mentioned in my own testimony about what the National Science Foundation is doing, testing the use of some AI techniques actually built with open software on making recommendations for panelists, for program managers. And it's an example of the broader challenge, I think, and opportunity of adopting AI tools and having folks in government use AI tools to help inform decision-making that they are. It's not going to be a magic press the button and get the answer out, but using that to help complement already existing activities.
Dr. Nakasone, maybe a more specific question for you. You mentioned 7.5 million different kinds of applications and tools that GSA makes available. Are there tools that other agencies are not taking advantage of and they should when it comes to this topic?
So when we speak about the 7.5 solution sets that we're talking about, you know, it crosses the scope of telecommunications, IT services, supplies, commodities, right? So we have access, and we are learning every day on how to build these solution sets by looking at use cases, best practices, and things alike, with, of course, the working groups that we have to understand how we can deliver these broader acquisition solutions to cover, you know, things like distributed ledger technology with the robotic process automation and the
let me ask it this way. We bring in a lot of federal CIOs when we go through the FITARA scorecard, talking about how are they modernizing their digital infrastructure. Give me a question I should be asking them. You know, are you using fill in the blank?
Right. So something that we could be asking is, what emerging technologies are you using to do your IT modernization uplift? You know, we recently GSA has a big part in the IT modernization plan, and I think one of the things that we need to look at is how are we leveraging emerging technologies and injecting it into our infrastructure.
Dr. Everett, wrap it up for us.
I think there's a temptation to think of AI as magic and as being able to solve all our problems. When you talk about implementing something that will be effective for the federal government, I think we should take the perspective of first understanding what the actual problems are and then working our way back towards how AI could actually address those problems. And not just upfront, but looking at what is the life cycle cost of implementing those technologies.
Thank you, Dr. Everett. The gentlewoman from Illinois is now recognized.
Thank you, Mr. Chair. I think we all agree that research and development is essential to continuing to improve the government's use of artificial intelligence. And in my opening statement, I talked about the concern about China passing us by. Are there any other countries that you think are putting a lot of money into research and development and are passing us by or could pass us by when it comes to AI? Whoever wants to answer.
The one that I hear about all the time is China. Certainly the international community, however, is very broad. And the AI community started out internationally in 1970. So the basis for the technology is international. Whether or not that is an issue at the individual country level, I don't know, aside from China.
I would again just add, I think it is international, so absolutely the comments that you had made in your opening statements about China. I'd note that DeepMind that Google has acquired is from the UK, that Microsoft acquired a really top-flight AI research company from Canada, and so really it's a global phenomenon.
And I think we all would agree that funding is extremely important so that you can continue the good work that you're already doing, and we can progress further. The other question is, beside funding, finding people that are educated and trained to help us progress in this area, and what are suggestions that you have of what we can do to find people interested in the field that want to get involved in the field?
So my suggestion is we need to make, so at the core of AI is computer science, and so it's making computer science attractive. And so again, depending upon the application area, cybersecurity, which is what some of us work on, is one of the most attractive, but we're still not attracting as many as we need. So we have to find those things that make it exciting. We've been, for example, funding competitions, high school and collegiate competitions, as a way to try to get students interested in cybersecurity and computer science as early as possible. And I think we just need to continue to push that agenda earlier in the school system. The sooner we can get youth interested in computer science as a career. They use the tools all day anyway, so let's teach them that there's a career in that direction.
I know when the statistic I show, it's amazing the difference between us and China, the people in the field and the PhDs graduating.
So I'd like to second Doug's recommendation about the focus on pipeline and also the importance of a broad computer science education. In my testimony, I had mentioned the computer science principles AP exam and how popular that has been. There are other investments that the National Sciences Foundation is making in exploring computer science in the middle schools. I think at the undergraduate level also, computer science now is becoming a much more popular major, and also programs such as what's called Computer Science Plus X, so it's the application of computing in other disciplines, and two grand challenges and two challenges that the country faces. And there's also a movement afoot of AI Plus X, so applying AI and data science for good. So I think at both the high school and the undergraduate level that there are programs afoot and universities innovating in that space. At the PhD level, we always face a challenge in that keeping PhD students in academia. There are lots of interesting challenges to be addressed in industry, and it's important to keep our PhD pipeline cranking at full speed as well.
So I guess one thing that GSA focuses on, you talked about recruiting, and we actively search out, go to universities, and also when we look at the diversity aspects, we are recruiting from a minority perspective as well. Just want to say for GSA's overall workforce, 40% are minorities and 46% are female, and within the IT field, we have 39% that are minorities and 33% that are female. So, we work hard to try to recruit talented and the best of the ability to try to get highly educated people into the workforce. And we have to, as we build out these emerging technology solution sets, I think by showing us we, federal government agencies, need to figure out how to get that message out there that, no kidding, we are leaning forward in building out and using emerging technology solutions.
How much do you rely on, do you think, AI relies on students educated outside of the United States to supplement the workforce? Whoever wants to answer. You can answer.
Sorry.
Don't be shy.
As far as that, I don't have that data in front of me, but however, we can take that back as a question.
Okay.
The distinguished gentleman from the great state of Michigan is now recognized for his first round of questions.
Thank you, Mr. Chairman. I think one of the questions one of the issues that's arisen as we look at adoption of AI and expansion of it is really getting a broader understanding of what it is and how it impacts our lives currently. Read a couple of articles recently where there's this, seems to me to be an innate fear of what AI is. How do we, at the federal level, overcome or get the level of understanding among the population as a whole, not the tech-weenie population, they all think it's cool, it's the other folks, about what AI is, how it makes decisions, and why it's of value to them if we're going to continue to expand investment and get more people into training. Anybody wants to tackle that, please go ahead. Mr. Maughan, you smile and chuckle. You're going to pass it off to Dr. Kurose?
Waiting to see if Dr. Kurose wants to go first.
Actually, I'm very happy to go first. It's a really great question, and it really comes to the question of decision making. And there have been computer and software-assisted decision-making for a long period of time. And when we do predictions, we do regression analysis. So, I mean, there's a long history of relying on computation to help in making decisions. And I think the key phrase that you mentioned was AI making decisions. And in the end, it needs to be people making decisions. And it needs to be people making decisions with AI software.
How do we get enough transparency of how that happens so that people understand that in the real world outside of here and a handful of other places? How do we achieve that? Because we need to do that if we're going to get the level of acceptance and engagement and education that we want. How do we achieve that, folks?
Right, well, so I agree 100%. It's absolutely a question of outreach. I think with some AI techniques that are in use today, there's an issue of explainability, which I think Dr. Everett and DARPA's had a program on explainability of AI, so maybe I could pass it down to my right.
Ping pong. Go ahead, Dr. Everett.
We are just starting a new program called Explainable AI, and it directly addresses the issue that a lot of the machine learning software that we have today cannot explain why it has come up with a particular answer. And so the objective of the research is to say, tell me why you think this is a certain kind of bird. And it will tell you, well, I think it's got a red crest and a black stripe on the wing, and then it will show you that it is actually looking at the right part of the image to start to build trust. Another aspect of this is assuring autonomous systems. So we have an autonomous ship called Sea Hunter, and to make it and to ensure that it would operate safely within shipping lanes, for example, it has to pass the commercial collision regulations. So we're looking at ways in which to use mathematical techniques to verify that the software will behave as expected in a wide range of circumstances that it might encounter in the real world.
You're not likely to get me on an autonomous ship in the near future, Dr. Everett. I have to be honest. How soon will that research and that information become available to the population on a broader level, do you think?
I think it will diffuse rather slowly, particularly as the popular culture tends to portray AI with a mix of science and science fiction.
Yes, and evil at some level, or fear of evil, let's put it that way. But let me get to my second question, as time is running a little short, is what's your agency's approach in dealing with the difficult question of ethics in the use of AI, which kind of goes to what you were suggesting? How are you approaching that with the general population, or even within your agency?
Certainly, I think that in the case of the research piece, we need to look at that, as I mentioned in my testimony. You need to make sure that the AI itself is transparent and understandable, and that you can actually see the decisions being made are balancing risks and are fair and just to the recipient of those. And that requires us to have not only the AI piece of it, but kind of watching the AI. How do I ensure that the AI is working and doing what it wants? I think we're still early in the day, but certainly agree that the ethics questions was raised in your industry panel as well.
Anybody else have any input? Go ahead, sir.
Yes, I'd like to say that I think the ethics question is also often very tied up with data and how data is used in inferences from data. It's an active research area. NSF is funding a number of activities there. I think it also calls to the front the importance of interdisciplinary collaboration here, because it's not just computer scientists and engineers, it's also social behavioral and economic scientists who have to be involved in this as well.
I appreciate my time has expired. Thank you, Mr. Chair.
The distinguished gentleman from the Commonwealth of Massachusetts is now recognized for his 5 minutes.
Thank you very much, Mr. Chairman, and to Ranking Member Kelly for your persistent attention on something I think that should be a huge priority for both Democrats and Republicans in this Congress. I do want to note that Ms. Kelly, in her opening remarks, put up a good slide there that demonstrated that the Chinese recent announcement, or in the last few years, announcement on AI, their intense focus and funding on that, has them eclipsing the U.S. investment. Not only because of their additional funding, but because the Trump administration has backed off somewhat on research and development funding for a number of our agencies. I know that that NSF is looking at a cut in funding of, I think, $9 billion. And I know that DHS as well. Especially in your Science and Technology Directorate, you're looking at I think it's a $1.3 billion cut. So I'm concerned about whether we're recognizing the priority with our budget as well. And you've been very helpful in terms of demonstrating the importance of this issue. But do you see any need for additional funding? And also, Dr. Everett and Mr. Nakasone, you see this as well. I know that DARPA has been considering projects from companies in my district, from underwater radar systems to enhanced antibiotics, for use against these resistant strains of bacteria, to climate change. And so we really do need, as Dr. Kurose has said, an interdisciplinary approach, but all of that is affected by the amount of available dollars for research and development. And we've had such great success in the past through NASA and other agencies where basically non-defense research has really helped us enormously across society. And I'm just wondering, Dr. Everett, or any of you, for the whole panel, do you see that the lack of funding here could trip up or basically prevent some of the wonderful discoveries and advancements that we anticipate in this field?
Well, DARPA supports the President's budget request for our agency. We are a projects-based agency. Our projects last roughly 4 years. Our PMs are not civil service, but rather they come from industry and academia for a limited period of time. So what that means is that every year, 25% of our programs are turning over, 25% of our PMs are new. This enables us to rapidly shift our budget to meet current priorities that we see emerging in the technology space.
Okay. Do you have any opinions about the National Science Foundation or in any part of HHS that also might benefit from further funding, or are we just talking about DARPA?
I'm speaking for DARPA.
Okay. All right. We got other witnesses as well. Mr. Nakasone?
Sure. Thank you for your question. When it comes to funding, as far as GSA is concerned, I just want to thank Emily Murphy, who is our new GSA administrator, and Alan Thomas, who's our FAS commissioner, and Kay Ely, who I work under, supports the efforts on the distributed ledger technology and the robotic process automation.
I'm sorry, you're eating all my time. I can't go with this.
Okay.
In English, do you think more money would help?
From a GSA perspective?
Well, that's who you represent.
Yes, I think.
Okay, that's good. Mr. Kurose, that's all I'm asking for.
Thank you.
Nothing complicated.
Just to say that the President's fiscal 19 budget request with the addendum funded NSF at $7.5 billion, which is the 17 enacted level. But to your question, I want to stress there is capacity to do more. When I mentioned that the National Science Foundation funds $122 million in AI core research, if we look at proposals that were not funded but rated either competitive or highly competitive, that's $174 million in proposals there. So there is capacity to do more.
That's helpful. Thank you very much, Mr. Chairman. I yield back.
My esteemed colleague from the Commonwealth of Virginia is now recognized.
I thank you, Mr. Chairman. And by the way, congratulations, I think, on your renomination last night, right? All right. Let's stipulate you all support the President's budget, and it's perfect, and you wouldn't change a word or a number. Let's stipulate that, so you don't have to demonstrate any further loyalty. We got it. But let's talk a little bit about the relationship between R&D and technological innovation and its impact on the economy. And I'm particularly interested in federal R&D. So, Dr. Everett, there used to be something called DARPANet, correct?
That's correct.
And what's it called today?
The Internet.
The Internet. So DARPANet, when your agency was smart enough to make that critical investment, were the commercial dollars flowing into that R&D effort at the time?
No, certainly not.
No, it was entirely a federal R&D effort. Is that correct?
That's correct.
And somewhere along the line, someone decided this is so nifty, this is so useful to us internally, that maybe it might have some other applications. Is that correct?
Yes, and I'd like to point out that it became NSFNet before it became
And then it
Internet.
became NSFNet. Thank you very much. Good point. So would that be the same story of GPS technology?
That would be.
So GPS, which is now ubiquitous, we all take it for granted. You can't even lie about getting lost going to a meeting anymore. Kind of put paper maps out of business. But GPS was also a federal R&D investment. Is that correct?
That's correct.
Your agency?
Yes.
What about robotics? Your agency get involved in robotics at all?
We just concluded the DARPA Robotics Challenge. So yes.
Yeah. So a lot of the research in robotics, again, a federal investment, your agency being one of the pioneers.
Yes.
Drones. Developed by the private sector, or was that a federal R&D investment as well?
Initially a federal R&D.
My goodness. What about noise cancellation technologies?
I'm not directly familiar with that technology.
Well, for example, we did a lot during the Cold War. We did a lot of hush-hush work, no longer hush-hush, on noise cancellation technologies for reasons you can surmise. But after the Cold War, when we were looking at civilian application for R&D in our possession as the federal government, we took noise cancellation out of your agency and out of the Pentagon, and we applied it to things like cars and even other things like parts of a room that we could cancel noise to allow privacy. We use it in courtrooms today. That all came out of federal R&D technologies for defense at the time. Human genome, is that your area, Dr. Kurose? Human genome research?
Excuse me, not my personal area of research, but certainly bioinformatics and computation plays an absolutely critical role
But
there.
the Human Genome Project, so that was run by some private entity in New York, right?
Golly.
It's not a trick question, Dr.
Okay.
Kurose. The answer is, of course not.
Of course.
It was a federal R&D investment. And I'm trying to make a point here. You know, there's a lot of loose talk about the government can't do anything right. That's not true. You four represent the face of a federal government that has transformed the world with its R&D investment, and we're not even talking pharmacological research. Almost all basic research in pharmacological areas is federal because the private sector won't take the risk. And right now we're counting on the federal government to save us from antibiotic-resistant bacteria that could, unfortunately, transform health worldwide because it's not profitable for the private sector to engage in that R&D right now. So we got to do it. But we've transformed the world. So when we say we're going to cut a couple of $1 billion out of federal R&D, and I look at this record, I tremble at what are we cutting? Is it the next GPS? Is it the next drone? Is it the next Human Genome Project? Is it the next internet? We don't know. But the opportunity cost, I fear, is enormous. And so it may be that DARPA is happy with the budget it's got. But this member of Congress trembles at a 21% cut that Ms. Kelly pointed out to us at the beginning in her opening statement, because there is an opportunity cost we can't calculate. We can't even know for sure. But I do know this. Whatever amount of money we spent on DARPANet, it was worth every cent. The return on that investment cannot be calculated. And that's true for GPS, and that's true for drones, and it's true for the Human Genome Project. These are investments worth making. And America does not make itself great again when it retreats from the field of R&D. So thank you for being here, and know that a number of us up here are going to continue to push hard for your budgets for the sake of the country. Thank you.
Mr. Krishnamurthy, you're now recognized.
Thank you, Mr. Chairman. Thank you, Ranking Member Kelly. I really appreciate the opportunity to be able to ask a few questions of our distinguished panel. Last month, I, along with others, including my distinguished colleague Paul Mitchell, who's on this subcommittee, introduced a bill called the AI Jobs Act, which basically requires for the first time that the Department of Labor study the impact of artificial intelligence on our workforce. You know, what areas of the economy are going to be impacted the most? How do we prepare our workforce for this artificial intelligence revolution and make sure that they are ready to take advantage of it, as some of you have talked about? I wanted to just start out with Mr. Kurose. What specific industries do you think are most likely to kind of experience the impact of artificial intelligence in our economy?
Well, thank you for your question and the interest here. Actually, I want to do a short promo, if I might, for a National Academy study on information technology in the U.S. workforce that came out just late last year and was funded by the National Science Foundation. And it was actually written both by economists. The committee that chaired this was an economist, Eric Brynjolfsson from MIT, and a machine learning professor from Carnegie Mellon, Tom Mitchell. And what I found very interesting about this, to answer your question, is that they talk about the broad application of IT technology and AI technology specifically across the whole U.S. workforce. So it's not so much a question of which jobs will be lost, which jobs will be created, but really how AI will transform work across broad swatches of the U.S. workforce. And again, not just even in automation in terms of robots replacing jobs, but also AI software helping doctors and lawyers and high cognitive skill jobs. And so I would recommend this to you and to everybody, just a very insightful report.
Right, right. Well, thank you so much. I don't know if robots will replace members of Congress. We might write a bill about that beforehand.
Sounds good.
Well, I want to switch subject to something that Congresswoman Kelly brought up before, which I thought was really important, which is kind of the rise of China in the field of artificial intelligence. I want to ask kind of the corollary set of questions, which is, how do we catch up and overtake them? What is our strengths in this area that we need to leverage to basically come back and eclipse them over the short or long term? Who wants to take? Dr. Everett, can you go for it?
We have a very different system than China, but I think we can leverage it. So I think, as Mr. Connolly pointed out, a lot of the original investments came from DARPA and from other parts of the DoD and the federal government that ultimately led to inventions such as the cell phone. If we look at the DARPA Grand Challenge, which in 2004 put up a $1 million prize for any car that complete a 132-mile course in the Nevada desert driving autonomously, no cars did, so we then had a 2005 challenge. 5 cars did at that time. That laid the basis for the self-driving car industry. So I believe that we are effective in de-risking technologies at the federal level so that we can then enable venture capitalists and well-funded companies to take on the substantial business risk to bring them to market and to make them reliable for consumers.
Mr. Nakasone?
Yes. Thank you for the question. I think one of the things we can do is do a lot of cross-collaboration, leveraging the Emerging Citizens Technology Office to convene, facilitate, collaborate, and help rapidly deploy, and also from an acquisition standpoint is have this private-public engagement and provide acquisition solutions so that we can support the entire federal, state, local government.
If I might add, it sounds like, I mean, both of your answers kind of include an element of the private sector playing a substantial role in the development of artificial intelligence. If I might, it sounds like one strength we have is that we are not necessarily going to pick and choose what is the best technology in any given sector of artificial intelligence. We may let the best one bloom, and then the private sector helps to fuel it, whereas in China, they might kind of decide something is the best, and it may not end up being the best. Is that a fair point? Dr. Maughan, do you want to comment?
Certainly, I believe, let the market decide. Let's let these new technologies come out that are AI-based, and those that are successful in helping people in their applications, they'll survive, and things that don't, they'll die, right? So let the market decide.
Great. Thank you so much. Thank you.
Mr. Mitchell.
Dr. Everett, I appreciate, my colleagues left, so unfortunately I asked them to stay because I promised him it'd be interesting. I appreciate the new things I learn every day as a new member of Congress. I've only been here about 14 months. I found out something new that you shared with me, so the internet was invented by DARPA?
That's correct.
So it wasn't a former politician, formerly a vice president?
It might have been popularized by a former politician.
Well, that helps a lot. I was confused about that up until just a few moments ago. A question for all of you, a serious question, sort of and sort of not, but I think I want to make a point. If I had a magic wand and could invent a giant wad of cash, a big bushel basket full of cash, around here it'd have to be $1,000 bills or something, maybe $1 million bills. Is any of you going to turn it down? Anybody here going to turn down more money? No takers. Exactly my point, which is priorities have to be made by your agencies, by the President of the United States, by Congress in terms of what it is, how we prioritize funding to get things accomplished on a broad range of things. And it's not a bushel basket that suddenly regenerates cash, or as I tell my teenage children, no, the cash machine the cash tree out back is currently bare. We have to make priorities. And at some point in time, there isn't enough cash for everything. So I suggest that if people want to spend more on this, we had a hearing this morning on transportation infrastructure on the highways and putting more money in the federal trust fund, highway trust fund. Decisions have to be made where that cash comes from. And I'm hopeful that there's concerns about artificial intelligence or how we fund our highways. that discussions can be held not just about how we either go further in debt or we tax more, how we save some money and actually find a way to pay for these things rather than expect the American public to just go deeper in debt or pay more taxes. I've not heard a lot of that from some of my colleagues. He left. It's too bad. So I appreciate your time, and I apologize for the little bit snarky question, but I think it made the point. I appreciate it. Thank you. You're back, Mr. Chair.
Dr. Everett, you said earlier one of the things that we should be looking at is in the federal government, what is the problem set that you have? What is the problem that you're trying to solve? And maybe there are tools that use machine learning or artificial intelligence. How do we get a senior manager in the government in that mindset? Who would they go to say, here's my problem? Are there other tools that I should be using to help improve citizen-facing services?
Well, that's a really broad question.
Does GSA have anything in their toolkit? Does NSF or DHS have a way, or here are some potential tools that could solve this problem that may or may not be being used? Do we need folks within the government to better define the problem set, and maybe Dr. Maughan goes out and finds some company that may be doing it and do some of that applied research you guys are so good at? Is that how we're thinking about this, how we should be thinking about this problem, Dr. Everett?
Well, a few years ago, we ran a program called XData, and it was in the area of big data analytics. We open sourced much of the software that we developed there. That software has subsequently been used by startups in the private sector. IBM has made a major investment in Spark, which is a big data platform. So this information that we have published it and made it available to the private sector directly. That doesn't get directly to your question, but it does at least start to enable the private sector to create solutions in this area.
Yep. Dr. Kurose?
Within the National Science Foundation, we're taking up a process of agency reform, and one of the pillars there is making IT work for us. And so, for example, understanding what are the open source tools that we may be able to combine to help us do our work more efficiently, exactly what you were saying. The example that I mentioned earlier about using AI clustering techniques to help program managers actually identify the most appropriate, really the best panelists and reviewers for proposals, one example of that. So having those decisions made locally and knowing what's available has proven to be very valuable.
So if we had someone in the U.S. Census Bureau that wanted to learn more, how would they do that?
Well, for this particular project, we could certainly put them in touch with people inside the NSF who are working on this project. Yeah.
Dr. Maughan, it looks like you were getting ready to say something.
Well, I was just going to say that, when we talk to operators in the field and they're looking for solutions, they don't necessarily say, I need an AI solution to my problem, right? They come to us and say, I need a new widget or a new this, but it looks like this. And then our job is to go find the researchers at the universities or the companies, and a lot of it ends up being, how do they think about solving it? And do they think about solving it in an efficient manner that can take advantage of new technologies? Because we are in an innovative country, an innovative mindset, and I think that's one of the benefits to an earlier question is, we do have an innovative community out there that really is trying to bring cutting-edge solutions to the operations community. The operations community don't know they need an AI-based solution, but if you give them a solution that solves their problem, they don't care if it's AI-based or not. They'll use it, they'll deploy it, the companies can be successful.
If we had Mr. Mitchell's cash tree, and let's say we had $100 million, and what kind of basic research should we be putting that towards? And Dr. Everett, Dr. Kurose, if you had a...
So I will say, and I will just echo what Doug Maughan said, we have a very, very creative community, and many of the best ideas they're bottom-up ideas. So we say to the community, here are broad areas that are very important. I might label a couple of some of the grand challenges I talked about earlier: explainable AI, fairness, accountability, transparency, and decision-making, for example, are all really, really important areas. The ideas are going to come from the research community itself.
I think you referenced $145 million worth of research proposals that you've been given that you haven't been able to fund, I'm assuming.
That's right, $174 million in
174.
artificial intelligence.
Wow.
Right.
So in our area, we are more project-driven, so we would have reach out to the community to find people interested in starting programs in relevant areas. One area I think that is very important for us to be looking at is common sense reasoning. That is what people are, people are so good at it, it's hard to even describe.
I know some people that may need help with that.
Computers are definitely challenged in this area, but if we're going to move past graphical interfaces with computers where they're simply tools, and computers are going to become more active partners in decision-making, we're going to need to imbue them with common sense.
And my last question, and whoever would like to answer it, what is the equivalent of going to the moon with artificial intelligence? Because I will say this, it's been interesting as we've been looking at this and talking to folks. I went out on the plaza of the Capitol and asked people about, what do you think about artificial intelligence? Is it good or bad? I was shocked at how many people are scared of it. You know, I think we've had too many movies where the robot with the plastic face that's getting ready to snatch you, right? You know, Will Smith. And so one of the things that we all understand the importance of this. I always, you know, if Vladimir Putin said that whoever masters AI is going to be the sole hegemon, we should listen. But to be able to explain this in a way to folks that don't have y'all's experience or background, what is that moonshot in artificial intelligence? Dr. Kurose.
So maybe if I could start, I'd come back to earlier in my testimony talking about narrow AI versus general AI. And in narrow AI, it's what we're hearing about: image classification, speech understanding, phenomenal leaps forward on that. But if you look at, for instance, what an 18-month-old child can do and how the child can transfer learning from one environment to another, how a child can understand intent and meaning, that's really the grand challenge. General AI still remains a very grand challenge.
I would second that. Right now, we're building tools, and the popular press makes it seem as if these are going to become autonomous and think for themselves, but that is very far from the actual case of things. Right now, we know that people learn by having as few as one examples, and yet we need terabytes of data to get our systems to learn. We may look back on this time as the era of incredibly inefficient machine learning. So a moonshot might take us to the point where computers actually do understand us in ways that our tools today don't. But what we have today are tools.
I would just add to something earlier said by Dr. Everett, which is the program at DARPA, which is the explainable AI. It may just be that the moonshot is AI that is just in and around us all the time, and we don't even think about it. We don't call it AI. It just is, and it works, and it becomes part of our everyday life, and we don't worry about it. And
it's not locking us out of our house.
Doesn't lock you out of the house, but it might just be that explainable piece that might be the moonshot.
Excellent. Well, I appreciate that, Dr. Maughan. I want to thank all the witnesses for appearing before us today. We're going to hold the record open for 2 weeks for any member to submit an opening statement or questions for the record. And if there's no further business, without objection, the subcommittee stands adjourned.